Water memory effects and their impacts on global vegetation, productivity, and resilience. Abstract. Memory effects refers to the impacts of the antecedent climate conditions on current vegetation productivity. This temporal linkage has been found to be strong in arid and semi arid regions. However, the dominant climatic factors that determine such patterns are still unclear. Here we find water memory effects as the persistent effects of antecedent participation on the vegetation productivity for a given memory length from 1 to up to 12 months based on satellite observations and climate data. We quantified the length of water memory effects and evaluated the contributions of antecedent participation on the current vegetation. Our results showed that vegetation productivity was highly dependent on the antecedent participation in arid and semi-arid regions. The average length of water memory was approximately 5.6 months. Globally, water memory effects could explain the geographical pattern and strength of memory effects, indicating that participation might be the dominant climatic factor determining the memory effects because of its impact of water availability. Moreover, our results showed vegetation in regions with low mean annual participation or a longer water memory has lower energy engineering resilience, that is slower recovery rate to disturbances. These findings will enable better assessment of memory effects and improve our understanding of the vulnerability of vegetation to climate change. Introduction. Memory effects can be defined as the independence of vegetation productivity on both contemporary disturbances and the residual effects of the past climate conditions. The occurrence of such high effects highlights the importance of considering time in ecological studies and provides an explanation for the observed relationship between antecedent climate conditions and the current vegetation growth. Indeed, there is a clear evidence that past climate conditions, including participation, temperature, and other abiotic factors, can significantly influence phenology, vegetation, productivity, and terrestrial ecosystem carbon cycles. However, the relationship between past climate conditions and current vegetation productivity is still poorly understood. Hence,